Hey there, stats enthusiasts. Welcome back to another lesson in AP Statistics. I'm Goldie and I'm here to take you through AP Stat Unit 1. I'm dealing with exploring one variable data. So this is going to be notes 2 in our series where we're going to go over histograms and ogives, or cumulative relative frequency graphs. These are going to be two graphs that we use to display quantitative data. We are going to talk about some other graphs that we will use as well, but we're going to cover those in later notes sections. Today, it's all going to be about histograms and these cumulative relative frequency graphs. So take out your notes, settle in here, and let's go over this content together. So starting off with displaying quantitative data in general. So we've talked about how quantitative variables are used with numerical data, and the way we kind of determine if something is quantitative is where operations like averaging make sense. Okay? Quantitative variables can be broken down into two types. We talked about discrete, how discrete represents counting variables, and continuous represents measuring variables. And we can use a frequency table to organize both of these data types and a histogram to display them. So quantitative variables can apply to histograms, and you can use discrete or continuous variables. And we're going to look at two examples, one with discrete and one with continuous. Okay? So discrete quantitative data, if I can say that vocab word 10 times fast, discrete quantitative data looks very similar to the frequency tables for categorical data. And a histogram for this type is created, again, similarly to a bar graph, with some key differences. In a histogram, the bars touch to both communicate that this is quantitative data and the fact that there's a relationship between the numbers, right? That it goes from lowest number to highest number. The x-axis must go in order from least to greatest, whereas with bar graphs and categorical data, we said that it could kind of be rearranged on its own. It does have to go in order from least to greatest on the x-axis here. The x-axis will be labeled with values between the bars, and I'll show you how to set that up. And the values communicate what values the bars contain, up to but not including the upper boundary, which if you're used to that, it makes it easy to read the graph. But if you've never seen that before or had to work with graphs that do that, it can be a little weird getting started with it. So I'm here to explain it. Let's just first look at an example that's already done for us before we construct our own. So if I asked a class to gather this data a couple years ago, how many pets do you own? Here are the results as a frequency table and a histogram. So we have two ways of displaying this discrete variable, okay? Because number of pets owned, that is going to be a discrete variable because you own one pet, two pets, three pets. We don't usually report decimal values for number of pets owned. So the frequency table over here, I have number of pets. Whether you have 0 pets, 1 pet, 2 pet, 3 pet, or 4 pets, there were no one in the sample had 5 or higher, so we stopped at 4. And then frequency. So how many students fell into each of those counts? Okay, so what we have over here is number of pets on our x-axis. It starts at 0 and goes up 1, 2, 3, 4, 5. Now, notice how I start at 0 here, a little bit off of the axis. That is just a style. You can start, because most people associate this right here in the corner with the origin of like 0, 0, right? You're welcome to start your bar there. And the way I make the graphs here, it has a little space. That is also a style thing. You're welcome to start a little bit off of the axis just to make it easier to read. That's up to you. And then I go up by 1. So 1, 2, 3, 4. Again, that's going to depend on your data. Here I go up by 1. Other pieces of data, maybe I go up by 5 or by 10 or by 1,000. It's just going to depend on your x-axis variable. Okay. So what is this data corresponding to? Because I start at 0 and then I go up to 1. So this whole bar right here goes between 0 and 1. Now, what is this data corresponding to? Okay. Well, it goes up to 10. So maybe you can kind of assume, okay, a frequency of 10, that's corresponding to the number of pets of 0. So this is the number of students who have 0 pets. And this is where it gets a little tricky if you haven't seen this. The lower boundary, when we look at a histogram, the lower boundary is included, but the upper boundary is not. So 0 is included, and I go up to, but not including 1 on my upper boundary. And that's how we label histograms and how we read histograms here. So 0 is included, it goes up to, but not including 1. Whereas this next bar starts at 1 and goes up to, but not including 2. So this bar right here represents students who have 1 pet, which are 7. This bar represents students who have 2 pets, 2. Students who have 3 pets, which is 3. And then students who have 4 pets, which is 1 student had 4 pets at home. Okay? So that's how we're going to be reading our histograms. Now let's make it. Okay, we're going to start off by making a frequency table and then making a histogram from that frequency table. I'll explain how to make a frequency table in the next example, but for now, let's just focus on the histogram part of it. So let's say for your high school football team, you looked at how many points were scored in each of the games they played in the past 5 years. And here's a list of all of the data. Holy cow, right? So this is, again, what we refer to as raw data, meaning it is unorganized, there's no order, and there's no clear pattern. So we want to make a frequency table to organize the data and then a histogram to kind of visualize that data. So we're going to fill in the frequency table below, and then we're going to make a histogram. So the frequency table we have, the scores are going to be intervals now. Okay, so with number of pets, they were a single value. Now we're going to get into ranges here, intervals, or I should be careful to say intervals of values. So for a score from 0 to 9, I'm going to count that in that first frequency. So there were 3 scores that fell between 0 and 9. Okay. So this is discrete data because when you think of the number of points you score in a football game, you're not going to score a decimal amount of points in a football game. So our scores reflect that. So I go 0 to 9, and then my next value starts at 10. So notice I don't account for any 9.5s or anything like that, right? Because it doesn't make sense with my data, right? So 10 to 19, there's 14 scores, if I counted correctly, hopefully I did, that are between 10 and 19, inclusive of those endpoints. There's going to be 39 scores from 20 to 29, 22 scores from 30 to 39, and then 7 scores from 40 to 49. Okay. So you can double check, count it, and just make sure I'm correct, but hopefully I am now. So that's going to be our frequency table. Okay. So that's always what we have to start off with first before we make our histogram. Okay. Now this frequency table, it has the same amount of values in each of the intervals. Okay, I want to point that out. Each interval has 10 possible values. 0, 1, 2, all the way up to 9. That's 10 possible values. This has 10 values. This has 10 values. It's very important when we make our histograms that we're making intervals that are even. Okay, they have to be even and they have to cover an even. I couldn't say 0 to 9, 10 to 14, 15 to 19. I can't do intervals like that. Okay, the intervals have to be even. Okay, so that when I go to make my histogram, the bars on my histogram have to be even. So here's the number of points scored in a game. Okay, so I labeled my x-axis, points scored in a game, and I labeled my frequency. Now notice I went up by 5s here, but I am going to go up by my intervals when I make the bars. So for my first bar represents the scores 0 to 9. Okay. But remember the way I have to make histograms, I have to go starting value. So I'm going to start at 0 and I have to go up to, but not including the last value on my graph. So I'm actually going to go up to, but not including 10 because this first interval doesn't include 10, right? That's not how we counted them. If I had a value of 10, that fell into here. Okay. So this first bar, it goes up to, but not including 10. So you're going to see 3. This is approximately 3 on my frequency. You're going to see 3 graphed there. Okay. My next bar goes from 10 up to 20. Okay. So it includes the values of 10, but not 20. Going to go up to, but not including 20. And there were 14, so I have that graphed just below 15 there. Okay. And I'm going to continue that way. 20 to 30 goes up to 39. Okay. 30 to 40 has 22, and then 40 to 50 has 7. Okay. Again, I go up by tens because there's 10 values in each of these. 10 values in each, but this last one is not included. Okay. Up to, but not including that last value. Okay. And that's something we'll get used to. It feels a little weird for discrete data. Students usually have an easier time with it when we move to continuous data, which we'll see in a moment. Okay. Continuous data. I say a moment, but here the time has arrived. Okay. Constructing a frequency table for continuous data looks a little different. We have to make sure that we don't have too many bars or too few bars. With discrete data, it's a little bit better because we can usually be a good judge of the number of intervals we need or the number of data points we need for our x-axis. It's a little harder for continuous data. So the continuous data we're going to look at is how many hours of sleep did you get last night? And students are going to report that as a decimal. Okay, how many hours of sleep they got last night. Now you can see these 2 bar graphs. Hopefully they look a little silly at first. The first one over here, hopefully this looks silly because there's a lot of bars, right? It's almost like what's going on, okay? Because, this bar represents one person who got how many hours of sleep? That's not too clear. This represents one person. It's a little strange, right? This one over here also looks a little strange because there's only 2 bars. Okay? Between 0 and up to, but not including 5, 2 people got this amount of sleep. Between 5 and 10 hours of sleep, 16 people. Okay? It makes it hard to see, both of these graphs make it hard to see what the data is telling us. Okay? What patterns do we see in the data? Maybe we can see one pattern, but it makes it hard to see other patterns, okay, and see as much as we can with the data. These graphs look silly because it's not that clear visual. And because of that, when we go to make our frequency tables, we have to make sure that we don't use too many bars or too few of bars. So as a rule of thumb, about 5 to 7 bars is really where we want to aim with each data set. How many bars? It's either going to be told to you in the problem, or it's going to be up to you as the statistician and the experienced data analysis person that you are. It's going to be up to you to decide, okay? But 5 to 7 bars is usually where we want to aim. Now, I do have steps for determining intervals and what intervals we need in order to make a frequency table. I just want to let you know that these are my steps alone that other people follow. But they're not like the rule, okay? Making histograms, it is because you are displaying something, it is an art form. And as we know with all art, it is subjective. It's the same thing with determining the appropriate number of bars. What I think is appropriate isn't necessarily what the next person's going to think is appropriate. On the AP exam, which is what you're training for if you're watching this video, on the AP exam, it's usually left up to you if you have to make a bar or a histogram on the AP exam. It's usually left up to you as the student to determine how many you think is appropriate, and they leave it up to you to do that. Okay. All right, so here's the steps I take. For people who like a very concrete, like tell me the steps, tell me what I have to do. Here's what I say. Calculate the range of your data set. Take the maximum value minus the min. So look at your highest number and look at your lowest number and subtract them, okay? Calculate the class size, okay, or the bar size, so the width of your intervals. Divide that range that you get, that number, by the number of bars you want. Again, that's usually between 5 and 7. If you want 5 bars, 6 bars, 7 bars, whatever you think is going to display the data correctly. If you get a decimal when you divide, round it, okay? Round it to the nearest whole number here. And then set up the class from there, okay? So do steps 1 and 2 to figure out what width it has to be here. So for number of pets, our width was 1. For points scored in the football game, our width was 10, right? We had a width of 10. Your width, it just depends on the data you're working with. So steps 1 and 2 allow you to see the data you're working with and come up with an appropriate width from there. Once we have that, we set up our classes, right, or our intervals. Our first class starts with the minimum value, and we add that interval size we got to get the next value on our x-axis. The second class starts with that value and adds it again to get the next value, and we repeat it for all of those classes until we cover that maximum value, because we got to make sure we cover that. The last class does not have to end at the max value, but should go, in fact, over it. In fact, the minimum value, our first class, doesn't necessarily have to start with a minimum value either, right? Like if our minimum value is 3, I can start at 0, okay? I just have to make sure that my classes cover from my minimum value up to my maximum value, okay? So here are some steps that can help you. You don't have to memorize these steps by any means. They're just more of a guide to help you get that histogram made, okay? So let's do this. When I asked how many hours of sleep students got last night, here was the data that was reported. And I do have it in order to make it easier on you, okay? So here's the data in order. We're going to create a frequency table and a histogram to display the data, and I'm going to use a class size of 6. So I'm told in the instructions what class size to use, okay? So here's what I do. I take the maximum minus the min, okay? And I come up with my range of values. So 5.5, right? So my max hours is 8. My lowest is 2.5. So my range is 5.5. So I'm going to take 5.5. I'm going to divide that by how many intervals I want. And I want 6 in the directions, okay? That's 0.92. And I'm going to round that up to 1 as my interval width, okay? So what that gives me, oops. I guess you get to see the hours of sleep last night. Try not to look. Is intervals of 1. Okay, so I'm going to start at 2 and I'm going to go up to 3. So this is an interval of 1. Okay, why is this an interval of 1? Because it starts at 2 and goes up to 3. This starts at 3, goes up to 4. Interval of 1. But it doesn't include this endpoint. So notice how 3 is here and here. Where is 3? Where would 3 be included? If a student got exactly 3 hours of sleep, which interval would they fall in? They would fall into this interval right here, okay? Because the upper boundary is not included. Now, the reason we have this interval, instead of we just say like this is 2, this is 3, this is 4, is because we have continuous data, okay? And with continuous data, we might have decimals. Okay, so we say 2 up from 2 up to, but not including 3, so that a decimal like 2.5 will fall in this interval. So I have a frequency of 1 here. From 3 to 4, I have 0 because I don't include the 4 here. I include the 4 here. From 4 to 5, I just have that 1. From 5 up to, but not including 6, I have 2. From 6, including 6, up to, but not including 7, I have 6 values. From 7 up to, but not including 8, I have, I have 7 values there. Sorry, I clicked off of my slides, so I'm trying to get back. And then from 8 to 9, I just have that one last data point there, okay, of 1. And that's my frequency table now. Okay, made and organized, and now I can make my graph. Okay, So it starts with hours of sleep last night. On my x-axis, I'm going to start at 2. Go up by 1 is my class size. And then I just fill in the bar heights with the frequency table. Okay. And that is how I'm going to make those frequency tables. With the histograms. Sorry, I did both. I made frequency table and a histogram. Okay, now let's switch gears and let's start talking about ogives. Okay, now in order to talk about ogives, we have to do a small thing on percentiles first. And you've seen percentiles before, and which is why I have this image up on the screen. So if you took the SAT, or really any standardized tests before, you've seen percentiles reported with your score. And that's an effort to tell you how you rank among other students who have also taken this same test. Okay? A percentile is represented either as a whole number percent or sometimes as a ranking, right? From 0 to 100. Okay? So like here, if you scored 1010 on the SAT, okay, 1010, you are at the 50th nationally represented sample percentile, or the 41st SAT user percentile. Okay, even down based on your sections, you are given percentiles. Okay, all right. Now, what do those percentiles mean? The number represents the approximate percentage of data in a set that is below a single data point. Okay, so those percentiles tell you the percent of students who scored below you on your test in this example, okay? So if you have this as your SAT score, okay, 50th percentile means that 50% of the students who have taken it in the nation have scored lower than that score, okay? On your reading and writing score, if you have a 44th, that means 44% of students scored lower than you on your reading and writing score. Okay, so the percentile represents the percent below. All right. Now, calculating percentiles is not an exact science, and there's actually not a universal agreement on a single procedure for calculating them. You'll see different opinions online about it. Okay, even different statistics textbooks do different things. For our course, for AP Stat, here's how they define calculating percentiles, and this is what you need to follow for a small data set. Okay, to find the percentiles of values, you take the number of values that are less than or equal to that value and divide it by the total number of values. You'll multiply it by 100 to get that percentile. But it's the number of values less than or equal to that value X. Okay. So for example, at Disney World, one of the rides is known for having an incredibly long wait time. The data on this website, they have the average daily wait time every day for this ride, for the park, in the last year. Now, this data I got is from September of 2024, and this was the average wait time per day for each day in September. Now, it goes in order here, or approximately in order. I guess I messed up a little bit there, but it's going to go, and we're going to find what percentile of the wait times of 66 minutes is going to be. So we have to find out how many wait times are going to be less than or equal to 66 minutes. Okay. And here's our data. Okay. So find the percentile of wait time of 66 minutes. So if you have a 66-minute wait time, what is that percentile? So the first question that comes up on the screen there is, first we have to figure out how many wait times are less than or equal to 66 minutes. Okay. Now, the data doesn't necessarily go in order from smallest to largest, you can see, but what I have highlighted are the numbers that are less than or equal to 66. Okay. How many numbers are there? There's 17 out of 30 total observations that are less than or equal to 66 minutes. So the percentile, I take 17 divided by 30, multiply it by 100, and I got 56.67%. And for percentiles, we always round down usually. Again, not a universal agreement, but for this class, you're just going to round down for percentiles. So that means a wait time of 66 minutes puts you at the 56th percentile. Now, what does that mean? Okay, you found the percentile, but what does that mean? That means that if you have a wait time of 66 minutes, you are at the 56th percentile, meaning that 56%, approximately 56% of all wait times of this ride are going to be less than 66 minutes. Okay? Okay, that brings us to ogives, because ogives are going to be created based on percentiles. So ogives, or what we call the cumulative relative frequency graphs, displays percentiles as an interval of variables. So these graphs allow us to visually see percentiles and answer questions involving percentiles. So to create an ogive, first you have to make a relative frequency table of your quantitative data. Now we've seen relative frequency tables before with categorical data, so let's look at a relative frequency table with quantitative data. So going back to hours of sleep a night, okay, I changed the intervals a little bit here, and the frequencies I'm going to have are a little bit different, okay? Now, I just want to use this as an example to get us to where we need to go, okay? So hours of sleep a night with the frequencies in each of them, and then let's calculate the relative frequency. Okay, so frequencies were counts how many fell into each interval. Again, this is based on a separate class's data, not the class we used to create the histogram. Okay, so I want to make sure you know that this is a separate data set. But I have frequency, I have the number of students that fall into each of those intervals. Now, relative frequency is a percentage. Relative to the rest of the frequencies, what percent fall into each of these intervals. So there's 18 students that were included in this data set. One of those students got between 0 and 2 hours of sleep a night. So we do 1 divided by 18 to give us 5.6%. The next, we take each frequency and divide it by 18. Frequency. So these are all relative frequency because it's relative to the other frequencies, what percent fall into each of those intervals. Okay. Now to get the cumulative relative frequency, then when you think of cumulative, think of accumulating. Okay, cumulative accumulates. Okay, and it accumulates the percentages as you increase your X variable. And the way I think of this is a snowball rolling down a snowy hill. If you have a small snowball and it starts rolling down a hill, it's going to accumulate snow as it rolls down. So by the time it gets to the bottom of the hill, you're going to have a big snowball. Okay, and that's kind of what cumulative relative frequencies do. Okay, if you can picture that, we start at the bottom, 0 to 2, the smallest interval or the smallest value of intervals. And the cumulative relative frequencies there starts at the smallest value. So just 5.6%, okay, to find the cumulative relative frequency. The next interval then, what we do is as we go through the data, we accumulate the percentages. So the next interval is 22.2 relative frequency. We're going to add that to the percentage above. We're going to accumulate from the 5.6, we're going to accumulate the 22.2 in order to get 27.8%. Okay. The next interval, we're going to accumulate from there. So we have 27.8% here. We're going to accumulate the next interval, which is 22.2. Okay, so we're going to get 50%. Then we're going to keep accumulating down the hill. So we have 50%. We're going to accumulate the next relative frequency of 38.9 to get 88.9. And then lastly, we have 88.9. We're going to accumulate the last relative frequency, add that, and we're going to get 100%. Okay? And the cumulative relative frequency always ends at 100%. If you have if you had to round some of these, rounding them, sometimes you'll get like 100.1 or 99.9. You might have some rounding, discrepancies, but it should always end at basically 100%. Okay. So that's our cumulative relative frequency. Okay. Now, Goldie, why did we just do cumulative relative frequencies? Well, with this table, we have two things. First thing, we just found percentiles. Okay, these are percentiles. These represent the percent below our interval values. Okay, so these are percentiles. The second thing is that this graph now, or this frequency table, is going to let us graph the data into a cumulative relative frequency graph, or ogive for short. Okay, so creating this ogive, here's what I have. I make my axes like normal. Hours of sleep go on my x-axis, and I'm going to label my y-axis as cumulative relative frequency. Okay. You could also label it as percentiles. You can just call it a percentile. That's fine too. Okay. But this is going to be an ogive of the number of hours of sleep students got last night. Okay. Here's my frequency table again of the cumulative relative frequencies we just found. I just put it horizontally. Okay. Now the rules for graphing this. How do we graph this? Well, the first interval here is 0 to 2 with a cumulative frequency of 5.6. So 0 is going to be my starting point, and my ending point, even though I don't include 2 in this interval, right? If a student got 2 hours of sleep, they're actually included in this interval, okay? But this interval ends at 2 visually, so the 5.6 is graphed right at 2. So that's my first segment on my ogive. My next segment, because the next interval is from 2 to 4 with a cumulative relative frequency of 27.8, I start at 2, okay, because that's where my last line segment ended, and I'm going to go up to the 27.8 on the 4. So this right here ends at 27.8. So you can see I make line segments here. So an ogive is connected line segments here. It's not going to be like an algebra graph where we're going to try to get it all pretty and curved. Don't do that. It's line segments that connect these points. Okay. And we continue that pattern until 100% is graphed at 10. Okay. So I'm going to move on to the next slide. So my next point after the 4, from 4 up to 6, that goes up to the the percentile of 50. So this is approximately, you can see 50 here. My next one goes to 8, and that goes to approximately 88.9. Oh. Okay. And then my last one is always graphed at 100%. Okay, so you can see this ogive is all of those line segments connected. Now from here, we can answer questions about percentiles, okay? So for example, how many hours is the 30th percentile, and what does this mean in the context of the problem, okay? Well, at the 30th percentile, let's see, how did we get 4.2 hours? So at 30%, 30 is right about here, okay? 30 is right about here, and we're at, I don't know, I'm trying to draw the best line I can. It's tough. It's tough out here. It's right about here. Okay, it's an approximation. Go with me. For about a little after 4, so I approximated it as 4.2 hours of sleep. Okay, so this is your percentile, is a cumulative relative frequency, it's percentile. And at the 30th percentile is about 4.2 hours of sleep. And in the context of the problem, this means that about 30% of the class only got 4.2 hours of sleep or less. Okay, so 30% of the class that I got this data from got 4.2 hours of sleep or less. Not good. You guys got to get more sleep. Okay. Or 2, we can go the opposite way. George got 7 hours of sleep last night. What is his approximate percentile, and what does it mean in the context of the problem? So 30th percentile, when we looked at that, percentiles were on our y-axis. So in this last one, I looked at 30 to figure out what hours that corresponded to. This is vice versa. I know he got 7 hours of sleep. So 7 hours is right about here. And again, I'm going to do my best to draw up and draw over, approximately the 65th, right? If I can draw up and draw over, that's about 65 is what I approximated it at, right? 7 hours is approximately at the 65th percentile. This means that 65% of the class got 7 hours of sleep or less, right? And that's how we would interpret it in the context of the problem. So percentiles, you have to know how to calculate percentiles for a small data set is difficult, again, because there's not just like a universal agreement on it. It can be a little bit tricky. But so calculating percentiles like we did with the Disney World dwarf mine, that's not something you typically have to do. You should know it, okay? You should know it. Not something you typically have to do. What's more important, though, is understanding what percentiles mean in the context of the problem and being able to read them from these cumulative relative frequency graphs, okay? All right. That brings us to the end of our show today. Okay. Thank you guys so much for following along. If you have liked this video, please hit the like button or subscribe to my YouTube channel for more great AP statistics content. Until then, I wish you endless statistical success, and I will see you in the next video.